Example 1, add 4 over x plus 6 over x plus a. What I want to look at when I'm adding fractions is the denominators themselves. And I'm looking for common factors before I start finding the least common denominator. What you'll notice here is that x is in both of these objects. But this x is being added to a, this x is not being added to a, that's just x. Okay, so I don't know what x or a equals, but I can't assume that x and x plus a are equivalent to each other. That would require that a is equal to 0, and I don't know that a equals 0. So I have to assume that let x be 2 and a could be 3, this be 2 and that'd be 5. They're not common, right? There's no least common. The least common denominator would just be the product of those two things. That's kind of what's happening here. So when I'm looking at finding the least common denominator, I'm looking at factors. And every factor is established by things that are being multiplied together. Things that are being added or subtracted represent pieces of a factor. So x is a factor and x plus a is a factor. Those factors are different factors. So the least common denominator is simply the product of those two factors. If either of those was the same, then I would, of course, just write down the highest power that occurs of the same one. But again, those are different, so x times x plus a is the least common denominator. The next thing I do, as I have in the past, is create a fraction with that common denominator on it, and then I need to make modifications for each individual fraction of the original problem. So the original problem is up here. 4 over x is the original first term. 4 is the numerator of the original first term, so it's going to go up here. And then I need to determine how the denominator that it had got modified to the denominator we want. What's new? X plus a is new. So I'm going to multiply that times x plus a. Okay, and now that piece is already fixed. The second fraction is plus 6 over x plus a. Make sure you put plus 6. Okay, if it was minus, put minus 6. All right, but it says plus 6, so put plus 6. And the denominator was x plus a. Now it's x times x plus a. What's new? X. Okay. So you just modify each numerator appropriately for how you modify the denominator for each individual fraction. The last step of these problems is to simplify. And those of you who like to check your answers in the back of the book, I have no problem with that. The back of the book is lazy on these. They stop there. I don't want to be lazy. I want to be very diligent, get these problems done as simple as possible. The bottom can stay factored, but the top must be completely simplified. All parentheses gone, all like terms combined. So, what's left to do? 4x plus a, we multiply 4 times both objects. That gives me 4x plus 4a. Then I've still got the plus 6x right here. That's all being divided by x times x plus a. Is that done?
No.
Why not? We have like terms, we had like terms. 4x plus 6x makes 10x plus 4a, which is an unlike term, all over x times x plus a. Is it done? Sure it is. Yep. Can't do anything else. Done. Alright. So again, back to the book a lot of times leaves it here. I want to get all the way down to here. And for that one it wasn't terribly difficult. As we continue on, you're going to see that they get a little uglier. I might recommend using some scratch paper on some of the simplifications.